My name is Caio Mucchiani. I am a PhD student in mechanical engineering here at the University of Pennsylvania. I work with Dr. Mark Kim at the GRASP lab. Today I'm going to show you guys how can we make robot manipulators more accessible. To make robots more affordable, there are two ways to approach this problem. The first one is simplifying the robot hardware, and the second one is simplifying what the robot does as a task. In this case, we want to simplify the robot hand. It's called the UR10 from Universal Robotics. It costs approximately $45,000. So as you can see, usually robotic mechanisms are kind of expensive. However, our idea here in our research group is to make robotics more accessible. In this case, what we're trying to do is to make the end effector or the robot hand more accessible. So when you look at conventional robot arms, right? The robot hand usually consists of a single motor or multiple motors, and they can cost up to tens or thousands of dollars. One of the greatest challenges nowadays in robotics is manipulation. So how can you grasp objects and interact with them, hand off objects to people? And the problem is, since nowadays we don't have this closed form solution, or putting in easier terms, we don't know how to do this in a unique way. We don't know if we might need just a single hand to do all types of interactions with objects, or we might need different hands or different robotic hands to do all different types of interactions with the object. So investigating in a way robot manipulation is trying to come up with an answer to that question. So when we look at babies and how they manipulate objects around them, let's say they're putting blocks on top of each other. They're not really concerned how they are picking the block and putting on top of each other. In robotics, we call that pick and place. This is one of the most well-known type of operations in industry. Let's say in the automotive industry, for instance, many cars use robots to pick parts from one point and place them somewhere else. In this case, what we are trying to do is to accomplish pick and place applications with a 3D printed fixed shape end effector, like this one. So we have one here in the robot arm, and we try to pick objects depending on the characteristics of the object, right? If you look at any baby, right, manipulating objects or just picking objects around them, it seems so easy and so basic, and we take it for granted for sure. However, if you are just trying to pick up an object using a robot arm, it can be pretty tricky, and I think it's this thing of like how something so simple, but by the way, by a computer, right? So how something so simple can be so difficult for a robot. However, very complex calculations can be done very easily by a robot. So it's kind of interesting. I think just again, we figured that out in robotics a lot, but once again, figuring that out was kind of an interesting thing. In this point in space, let's say we can represent this point in space using a Cartesian system, for instance, right? So we have the X coordinate, the Y coordinate, and then we can represent this point in space using these two coordinate systems, right? So I can represent this point in space using a Cartesian system, where I give it an X and a Y position. In fact, I can represent any point in this two-dimensional space with an X and a Y. And let's say I want the robot to go from one point to another, right? There are infinite ways that I can do that. However, for the robot to go through the shortest distance, all I need to do is calculate the distance between these 2 points as a line segment. So specifically, this robot arm mimics kind of like our arm, although our arm has 7 degrees of freedom. In other ways, it can move in 7 different ways. This one has 6, which is able to achieve any point in space within its workspace. So as you can see, we have 1 degree of freedom from the base, a 2nd degree of freedom from the shoulder, a third degree of freedom from the elbow, a fourth degree of freedom from the wrists, the fifth degree of freedom also from the wrists, and the last degree of freedom here, moving the end effector. So the advantage of making low-cost mechanism is able to achieve the same type of tasks as you would achieve with a conventional one. And this is what we are trying to do in this study. Specifically in this one, we worked on the hand, or the end effector, and the theory behind being able to grasp the objects using the arm and the hand. What we do here is we use physics, right, or acceleration, to maintain the object within the end effector without squeezing it, but still able to grasp it. I want this type of motion, right? I want this type of state, right? Safe against gravity. This is not safe, right? So if I apply some acceleration, right, I'm able to go from an initial state here to a goal state just by applying acceleration to the object. So that's kind of the idea. So I'm applying an acceleration to let the object stable within the end effector. What I also focus on my research is working on service robots, which is a definition for robots that can help in some sort of tasks. In that case, it's for older adults aged 65 years and older. They live in nursing homes, and they have some sort of limitation, be that grasping objects. So we want to make robots that facilitate any type of tasks. They might need a human for that. And so we want to make them more independent in a way. So that's why we're trying to investigate how can we have a robot help an older adult be more independent, yet freeing the human caregiver or the human healthcare worker to do what they do best, which is caring for the older adult.
Hi, Mrs. Jones. Stopped by to remind you to drink water, because staying hydrated will help you feel good. Would you like a bottle of water?
Yes.
Okay, please take a bottle.
Some consider a cell phone a robot. Back in the days, cell phones were extremely expensive. I'm pretty sure many of you guys watching wouldn't even remember, but cell phones were only accessible for the rich. Nowadays, you can buy a cell phone pretty cheap, and I'm pretty sure most of you might have. So that's the idea behind robotics being more accessible. Right now, it's like, it may be a higher cost, or for instance, the robot arm that I'm doing the demo costs around $45,000. However, the idea behind the research is making something that more accessible. The high school folks, I would highly suggest, physics is always interesting and definitely important, but if you do have computer science in your high school, any programming language, I think nowadays with artificial intelligence, it is important, and even for jobs down the line, I think if you do engineering and you just think you're gonna work on hardware, that's not very realistic. Like we're doing PhD in mechanical engineering, however, we spend most of our time in a computer. So you can see that for sure, like being able to have this computer science experience, I think is very important. So I would advise for some computer science, some physics, mathematics, those would be like my picks. To be honest, like just waking up and working with robots, I think it's just phenomenal. Like sometimes we have hard time believing that we're doing stuff like that. And like you see friends in your lab, Discovery Channel comes here and talk to them. You see friends in your lab, NASA contacts them to find out their research, you know, how can they modify stuff to add to their aircraft. So it's just amazing, like the people that you are surrounded by, the professors, their expertise, world-renowned people. I think, yeah, it does feel like a dream for sure, for sure.